Good evening, everyone. Thank you for joining us and welcome to the Longtom Watershed Council's August webcast. I'm Clinton Begley, Executive Director for the Council. Before we begin, I wanted to first acknowledge that the Longtom Watershed lies within the traditional homelands of the tribes and bands of the Kalapuyan peoples. Following treaties in the 1850s, the Kalapuya were dispossessed of and forcibly removed from their indigenous homeland by the United States government. Today, many descendants are citizens of the Confederated Tribes of the Grand Ronde and Confederated Tribes of Siletz Indians. We acknowledge that we are on occupied lands and express our respect for the Kalapuya and all tribal nations of Oregon and the important contributions they continue to make to their sovereign nations, all our communities, including the stewardship of this watershed. We're also committed to not letting that statement begin and end simply with an acknowledgement. We're committed to listening, learning from, and supporting Indigenous peoples. We're committed, and we are working to live that commitment every day. Valuing the collective wisdom of our community and building relationships has been at the core of our approach for almost 25 years, and we will continue to be important moving forward. Our efforts to support and learn from tribal people is no different and directly supports our mission that has guided all we've done for nearly 2.5 decades. Thank you for being here tonight. I'm going to turn it over to Rob Hoshaw, who will take it from here.
Thanks, Clinton, and welcome everybody. Thank you for tuning into part 2 of our summer webcast series featuring the effects of climate change on forestry. I'm Rob Hoshaw. I'm the Operations Director for the Council, and we're really excited tonight to continue this conversation and invite in Lauren Grand and Amanda Rao of OSU Extension to talk about the effects of climate change on the timber and forestry communities. Part 1 was a couple weeks ago on July 27th, and we learned from Dave Shaw about how hotter and drier conditions are increasing the susceptibility of forests and in particular tree species to infestations from different kinds of insects and disease. And then Glenn Howe talked about how these more extreme climate conditions can alter the distributions of tree species in our region over time. And in case you missed that broadcast, you can watch it. Again, that was recorded on July 27th, and it's on our YouTube page. So tonight, the conversation is going to focus on 2 main areas. Lauren is going to talk about managing forest land as a way to sequester or store carbon. And then Amanda Rao, who is the fire program specialist at OSU Extension, she's going to talk about wildfire in our region. Given all that's been going on with fires in the region and heat waves and concerns about both of those, this is a really timely topic, I know, and a lot of things that are front of mind for folks. And so we're really looking forward to these talks. And once again, we're excited to be partnering with Oregon State University Extension to bring their expertise to you on this topic. And want to thank all 4 of our speakers, Lauren and Amanda today, and then Glenn and Dave from last time, who've been really generous with their time and expertise in helping us to bring this information to you, the watershed community. So there's going to be an opportunity after each speaker to ask some questions. As before, when we've had these virtual broadcasts, there is a chat box on the right-hand side of the YouTube channel. Feel free to enter any questions or comments you have in there. And then we will, at the end of each speaker's presentation, take a few moments to relay those questions to them and incorporate them into the broadcast. So without further ado, I'm going to kick it over to our first speaker, which is going to be Lauren Grand. And if you watched our supplementary video featuring Lindsay Reeves and Tom Bowman of Bowman Tree Farm, you'll recognize Lauren as the person who provided the awesome biological context for Douglas for bark beetles, and also talked about how trees use competitive advantage to succeed more readily in under certain site conditions. So Lauren is a forestry and natural resources extension agent for OSU Extension, Lane County, and her areas of expertise include small woodland management, community forestry, fire and forest ecology, and conservation management. Welcome, Lauren. Really excited to have you, and feel free to take it away.
Great. Thanks, Rob. I'm really excited to be a part of this program and share this information. So I'm going to get my presentation going, and just let me know if you have any trouble seeing anything. Okay, great. I'm assuming silence means we're good to go. So
all looks good on our end.
Okay, great. Thank you. As Rob mentioned, I'm going to be talking today about managing forests with carbon in mind. And we can't talk about managing forests or with carbon in mind without first talking about the carbon cycle. So it's just a quick reminder, and there are a lot of versions of the carbon cycle, but this one is a box and arrow diagram. And the boxes, or really in this diagram, the parentheses represent the pools of carbon, and the arrows represent the fluxes in carbon. A carbon pool or stock is a place that has the capacity to store or release carbon. And a carbon flux is the amount of carbon moving from one stock to another over a specified period of time. And so in the green in this diagram, there are the land fluxes into the atmosphere from plant respiration and decomposition. And those are balanced with removal from the atmosphere through photosynthesis. And then similarly, carbon dioxide is released from the ocean is balanced by the uptake by the ocean. So both the land and ocean systems are, for the most part, in balance, or you'll see that mostly they store carbon in the vegetation and in the ocean. The anthropogenic activities that are shown in red, however, don't have a counterbalancing process, and this results in a net atmospheric increase in carbon. And so fossil fuels release carbon when they're burned, but because they take millennia to form, they're not pulling any carbon out of the atmosphere. So you may have noticed that the total carbon stored in the land, fossil fuels, and the ocean is quite a bit more than in the atmosphere. So we really want to make sure that we're keeping these systems in balance so we don't end up with excessive amounts of carbon in the atmosphere, which increases the effects of greenhouse gases and might increase issues related to climate change. So this is just another way of looking at it, and it's just a reminder that there's a fixed amount of carbon on Earth. So when carbon isn't really created or lost, it's really just moved into a separate pool. So the diagram on your left is the total carbon that's on Earth, and then in the middle is how it could be split up between the different pools. And so and then the one all the way to the right shows you that when carbon is removed from the atmosphere or gets smaller in the atmosphere, then it has to increase somewhere else. So if we're decreasing it in the atmosphere, we want to increase it on the land surface. So let's say we plant more trees and we absorb more carbon that way, and less is in the atmosphere. So that's just reminding you that we can't change the total amount of carbon, it's just moved into different pools. And then we also want to focus on the forest sector, and we can view the carbon cycle of forest vegetation, and we want to include these human-based activities as well. And so the green boxes are the natural activities, and the blue boxes are human activities. Here you can see that the additional carbon pools created from human activities, such as harvested wood, energy inputs from biomass, and wood products. These all interact with those natural pools of live vegetation, downwood, standing dead vegetation, and the forest floor. And so both these human and natural parts of the cycle have implications on forest management and carbon management. And so we want to consider both and try to understand both when we're making decisions about management planning around carbon storage and sequestration. And so this is just another way to look at that as well. So this is an example about how, sometimes we can make the wrong conclusions or information can be misleading when we don't consider all of those pools. And so the top shows, or on the left is the amount of carbon before a treatment happens, and on the right is after the treatment. So if we interpret the amount of lost as the amount going to the atmosphere, we can see that our conclusions can change depending on the level that we examine the system. So while a management action or disturbance might result in a great deal of live carbon being lost, some of it might end up in dead carbon pools or in forest products, and then some of it in the atmosphere. So it doesn't necessarily all go into the atmosphere if we lose it in the live carbon. So we just want to consider all of the pools that the carbon can go into when we're thinking about management. The U.S. Forest Service has a forest inventory and analysis program, and it estimates that just under half of Oregon's stored forest carbon is found below ground in the soils, and about a third of it is above ground in the live trees. And then the remaining carbon is distributed among the roots, downwood, the forest floor, dead trees, and understory vegetation. So about 75% of the carbon in Oregon's forests is in the soil and in live trees. And so those are great places to focus on making sure that when you're doing management activities, you're protecting those resources so that that carbon stays there for long periods of time. In addition to knowing where carbon is in the forest, it's also important to think about how long carbon will remain in each one of those pools. So this diagram shows the length of time that carbon is stored in each of these pools in the forest before it returns back to the atmosphere. And so you'll notice that these are somewhat related to decomposition rates. And I also want to note that there are multiple types of soil carbon, but this table just shows one example. So ideally, if you want to manage forests for carbon pools, then you'll want to continually add to those that store carbon for the periods of time that they reside the longest, so in the wood and in the soil. So I just want to throw out there that this is a continually developing field and things are changing rapidly in the information that we know and understand. But these are generally the actions that you can take that might reduce the sources of greenhouse gas emissions and enhance carbon sequestration and storage in forests. The first to consider is to increase or to maintain forest land. And the three categories in that are to consider are avoided forest conversion, reforestation, and afforestation. So avoided forest conversion or deforestation is what I'm going to talk about first. And that's the conversion of any forest land into a non-forest use. And it's substantial and it immediately reduces the forest carbon stock by cutting and clearing the trees. And forest loss is a major historical contributor to climate change. In a conversion scenario, there's no plan to reforest, and it's a human-induced change, like, for example, turning a forest into an agricultural field or a parking lot. And so when a forest is converted to another land use, carbon emissions occur from the loss of the carbon stored in the trees, roots, standing dead wood litter, and understory vegetation, and then also from the decomposition of that soil organic matter, which is slowly released through time. Reforestation is a direct human-induced conversion of non-forest to forest through planting and seeding. And this can be used to recover after a natural or human-caused disturbance. So after, let's say, a wildfire, like Amanda's going to talk about today, or after a human-induced disturbance, such as a clear cut, for example. And reforestation is one of the largest nature-based climate change mitigation pathways. 42% of global reforestation climate change opportunities were identified in lands now used for grazing, and now only 4% of those lands need to be converted back to forest lands to meet today's carbon emission goals. So forests can make a huge difference. There are specific tactics that you can use to be able to enhance reforestation efforts, such as considering immediately reforesting following a harvest or natural disturbance. Obviously, it's the law to do it immediately after a harvest, but if you're able to do it after a natural disturbance, that helps things out quite a bit. You'll want to think about planting species that are better adapted to future conditions. So thinking about what your property looks like now, or what the lands look like now, and what they might look like in 40 or 50 years, considering maybe some of the things that Glenn Howe talked about earlier in the series. Planting species that are more resistant to insect pests or pathogens. So if you happen to have a pest that's pretty prevalent in the area, maybe considering a species that isn't susceptible to it. So for example, if there's a lot of root rot, laminated root rot in an area, you might consider planting cedar instead of Douglas fir, which is less susceptible. And then also consider planting larger individuals or seedlings that can be appropriate to speed carbon accumulation. So the larger they are, hopefully the more carbon sequestration that they can do more quickly as they're adapting to this site. And then larger seedlings are also better at when they have a larger root system anyway, they're better at adapting to areas that are experiencing drought or cold weather. And then the third thing was afforestation. And really the difference between afforestation and reforestation is the time between the two. And so afforestation is that there wasn't a forest there for a significant period of time. So for 50 years, for example. And, you know, the biomass and clearing and site preparation prior to afforestation activities can cause short-term carbon losses on the site, but the benefits of a forest can offset those pretty easily, in addition to carbon storage through water filtration and erosion control. I do want to make a note that there are other habitats besides forests that are really important. And a lot of them are often carbon sinks themselves. So it's more beneficial to convert an old farm or pasture land or area that's gone fallow, you know, that's not being used anymore, into a forest than something like a prairie or an oak woodland, which is valuable habitat. And we want to keep those habitats for other resources. And they also do have considerable carbon accumulation rates on their sites as well. So really only thinking about putting in forests where it makes sense and it's not going to degrade other habitat types. So another opportunity there is increasing forest cover in urban areas where things like empty lots or mowed park lawns exist. Okay, so the second section that I'm going to talk about today is maintaining or increasing carbon stocks. And the goal here is to increase the overall carbon density and storage on a landscape, potentially in harvested wood products, by undertaking management activities to sequester additional carbon when compared to normal management. And I just want to point out here that normally if you are practicing sustainable forestry, then you are doing a lot of the work already in order to maintain good carbon storage and sequestration. The first thing to consider is we want to avoid degradation. So when trees are mature, we want to avoid management activities that would degrade them. So our goal is to avoid reduction in forest biomass due to unsustainable harvesting, forest use, or landscape practices. So in other words, we never want to remove more trees than our sustainable yield. So which means that we wouldn't be, if we were to remove more than the sustainable yield, we could run out of trees before they were to be able to grow back. Or if we were to high grade, which is basically meaning that you take the best trees and you leave the rest. And that's a poor practice in forestry that degrades biological diversity and causes a lot of health issues on the stand. So it's very rarely used, but we want to avoid those two things when considering carbon management. And then additionally, not just keeping forests as forests, but keeping forests as healthy forests. So we want to make sure that we're minimizing best we can disturbance agents, because disturbance reduces carbon holding capacity, right? Disturbances kill trees or damage trees, which means they perform photosynthesis less efficiently, which means that they take carbon out of the atmosphere less efficiently. And so we want to avoid activities that we want to help forests better recover from disturbance and avoid degradation. So let's dive a little bit deeper into disturbance. So disturbance is an event that changes the structure and composition of a forest ecosystem, and it's beyond the growth and death of an individual organism or tree. So this, for example, this photo is a disturbance of a landslide, and it's a landscape scale issue that harms or kills more than one tree. And this plays a large role in how carbon flows through forest systems, because disturbance, as I mentioned earlier, kills trees. And so there's two implications here. The first is that dead trees no longer uptake carbon by the ecosystem, and then dead trees and add biomass carbon to the decomposition pathway. So that's the dead material pathway that slowly releases CO2 from the ecosystem as it decomposes. So disturbance overall results in a net loss of ecosystem carbon or a net reduction in carbon sequestration. at least in the short term. So disturbance can impact carbon storage immediately by killing trees and then slowly over time through the decomposition, as I mentioned already. So while these can be seen as a loss, it can also be an opportunity to start planning when you start to notice that an unhealthy situation is occurring and support healthy forests into the future. So you can do that in a few ways. The first approach is to enhance forest recovery following a disturbance. So like I mentioned with reforestation, planting as soon as you can. So reintroducing those plants as soon as you can means that there's less lag time in the ability to start to sequester carbon on the site. You want to maintain or restore diversity. And by increasing diversity, you're able to help to mitigate the opportunity of a wide-scale disturbance in the future from a biotic issue. So for example, an insect or a disease. There's very few insects or disease that affect multiple species. Usually they target one or a couple, and usually not all the same species in our ecosystem. And so diversity helps in that way. And then reducing competition for moisture and nutrients by making sure that you're keeping the trees at a healthy, safe spacing. And then you also want to protect the site, consider those future adapted seedlings and saplings, and minimize animal damage to newly planted seedlings. You also want to consider taking steps to reduce carbon losses from wildfire. And Amanda's going to talk a lot about this in the next session, so I'm going to not speak about it too much, but you want to consider what's appropriate for your location and making sure that you're reducing fuels mechanically or with prescribed fire. And thinning stands to reduce fire risk in drought-induced areas. Has a lot of research has shown that it overall is, while it reduces the carbon on a site, the carbon holding potential on a site in the short term, it protects from a wide-scale carbon release if a catastrophic wildfire were to come through. So that's a management decision that you have to make. You decrease the amount of carbon in the short term to help create a healthy forest into the future, or you keep more wood on the stand, holding the most carbon possible, but run the risk of a fire coming through and losing a large portion of that carbon to a fire or insect disease outbreak in the future. So that's one of the trade-offs that you have to consider when managing a forest. Okay, some of the other things that we want to consider in order to increase carbon on the landscape is preventing and removing invasive species. Invasive species can often outcompete our native species, reducing biodiversity. And then also in a reforestation situation, they can reduce tree growth, which reduces our carbon sequestration capability. If you're doing a harvest operation, you want to consider increasing the structural complexity through the retention of overstory trees and in living and dead wood. And so you'll consider leaving large diameter legacy trees or consider using uneven age management techniques to leave some of that carbon on the site. And then if you're doing some site preparation afterwards, you can reduce land clearing and burning of slash and consider leaving small, low piles spread out that can degrade slowly, and those piles actually help with wildlife habitat instead of burning the slash. And then you'll want to consider managing for species that maybe have a wider moisture and temperature tolerances because of there seems to be an increased drought conditions in the summer and longer periods without moisture in the summer than we're used to. So for example, Willamette Valley ponderosa pine has a large tolerance to flooding and drought and tolerates extreme temperatures as well. Okay, so thinking about maintaining or enhancing sequestration capacity through forest alteration. So you probably heard a lot about this from Glenn Howe's presentation. This is an experimental theory, and some find it to be controversial, but the idea is that we alter the characteristics of a forest through intentionally through changing species composition and structure in considering the desired future conditions of the forest, specifically changed from their current conditions. So we hope that these changes create ecosystems that are better adapted to where we think temperatures and drought conditions will look in the future. And therefore, fewer trees will die, fewer planted trees will die, and therefore the longer the trees live, the more carbon they can sequester and store on the landscape. Because remember, when trees die, they slowly release the carbon that they have. So this is an example prediction from BC, and I'm going to flip through them from through the timeline, and you'll notice that the colors tend to move northwest, with the coastal west being the least affected. And so some of the approaches here is that we consider using seeds and seedlings from across a greater geographic range. We target the removal of ill-adapted species. So if you have a species that's at the very edge of its range, you might not consider planting that species again. Or consider species that grow really rapidly. Another thing to consider is to incorporate carbon into your harvest planning. So one thing to note is that when you're doing any type of harvesting, any reduction in the leaf area will reduce productivity in the short term. The greater reduction of the leaf area lost, the longer it will take to recover the carbon that's lost. So harvesting and processing trees does involve fossil fuels creating emissions outside that natural carbon cycle, and harvesting trees in a thinning operation would prevent greater emissions of carbon in the future if it makes the stand more resistant to disease or fire. So those are just things to consider. So you'll want to evaluate whether you use an even-aged or uneven-aged system based on your area. So that's really important to consider, and the ecology of the forest lands that you have or that are in the area. And the carbon impact for each strategy will depend on the time horizon of your management plan. So for example, even-aged forests usually see short-term increases in losses, whereas uneven-aged forests see a slow and steady rise in carbon stocking. And when you're, like I said, when you're selecting the method, you want to make sure it's appropriate for your stand of trees. So this example shows how harvesting reduces carbon stocks. The greater the intensity of the harvest, the greater the reduction. So the left panel shows what we would expect in a clear-cut system, and the panel on the right shows the changes from an uneven-aged system. And an important trade-off to consider when managing for carbon stocks is that forest owners can maximize forest carbon storage or forest carbon uptake, in other words, sequestration. You cannot maximize both. You can maximize carbon stored, but achieve little uptake when you have an older forest or you're managing for uneven-aged approach. Or you can achieve rapid rates of carbon uptake, but store little carbon in young forest when you take the even-aged approach. So you'll notice that traditional industrial management does not manage for old growth and mature forest conditions where the greatest carbon storage occurs, but there can be important carbon benefits of industrial methods, specifically with sequestration rates. And arguments usually develop over forest management policies related to carbon mitigation, where more ecologically oriented persons focus on the high carbon storage of older forests, while more production-oriented people usually focus on the high rates of carbon sequestration in younger forests. And both really do have a lot of value on our landscape, and both are important to keep in mind and can be balanced on the landscape. So if you have interest in both, you can think about managing different parts of your property, or if you're in an area where those different parts can be managed, some areas can be managed for older forest where we retain the storage, and some parts can be managed for sequestration where we might need to be able to make wood products from. Okay, when you're thinking about incorporating carbon into the growth of the stand, you want to enhance the productivity as much as you can. So if you have a poorly stocked stand with a lot of mortality, you want to plant more trees in those areas. You can consider using improved or superior stock trees, which means that they're selected to grow better under your local conditions. And then you'll also want to use proper density management. In forestry, we call that using relative density to maximize the growth on your stand. And so you want to maximize the wood growth on the stand so that you can sequester the most carbon, which will either lead you to multiple years of sequestration or leading the trees to a older forest storage carbon situation. And then also, I mentioned this earlier, but protecting regeneration from herbivore damage. And so if you have a lot of herbivore damage, it slows down the growth of the trees and their ability to photosynthesize. And a lot of people ask me about fertilization. I just want to note here that fertilization is often used to achieve growth, which in turn does benefit carbon sequestration. But when you fertilize, there's a lot of nitrous oxide released in the fertilizer production, and so that's a trade-off that you'll have to make, and that's a greenhouse gas. So something to consider when you're considering fertilization. And then also, when you're harvesting trees, you can think about carbon storage during harvesting trees by one, either reducing harvest altogether, and this can be a reduction in the area that you harvest or the extended rotation plan, and I'll talk a little bit about that on my next slide. And then you can also reduce the impact of harvest by changing logging practices. So usually in this area, we are using the most efficient logging practices that actually minimize a lot of loss of carbon on the site already. But things to consider are you'll want to reduce, so this is a good opportunity to reduce soil disturbance. So a lot of the issues with carbon loss in terms of harvesting is related to soil disturbance. So when you're harvesting, obviously you disturb the soil quite a bit. So using aerial systems or cable systems have the lowest impact on the soil, and so those will help reduce the most soil disturbance. Those are obviously expensive and not always applicable in smaller jobs. And so in those jobs, using mechanized systems where you can pile slash and then drive over the slash actually reduces the impact on the soil and causes less erosion. And so there's techniques that you can use to be able to reduce that soil disturbance. And then also there's a lot of, you'll notice in this photo, there's a lot of waste here, a lot of wood that goes unused and left on the site. And so making sure that you're marketing to the proper mill that matches the wood that you have is really important so that you don't have this is what's called long budding, as when you cut off a large piece of the end of the tree that you don't use, that doesn't go to the mill and gets put into a wood product that has a long residence time as opposed to being left on the site. And then, so this is an example of being able to extend your rotations. So extending your rotations is a great technique because the trees grow longer, they absorb more carbon, and then they store the carbon, right? And so the top example is sort of a financial rotation objective, where your main objective is getting as many rotations in to increase the amount of income from that stand. And so the second situation is when you're harvesting the trees at peak productivity. So this is when the carbon sequestration really starts to slow down. And so you sequester as much carbon as you can before it slows, and then you harvest, and you can get 2 harvest systems in. And then the third situation is when the rotation is extended beyond that peak productivity, and you're sequestering the most carbon, but you're only getting 1 rotation or harvest out of it. And so depending on your objectives, any one of these could work for you. But ideally, in the second scenario is when you're maximizing both the carbon sequestration potential and the number of harvests that you can do. And so it's sort of finding that what works in the middle compromised situation, if you have both of those objectives that you'd like to meet. And then I do want to touch on old growth forests here. Old growth forests do tend to store considerably more carbon than working forests or forests that have shorter rotations and across the different pools, and that's because of their undisturbed nature. But there were still a lot of questions about whether they provide carbon sink benefits. So there was a lot of concern that because there's so much dead wood in old growth forests, that they're actually a carbon source as opposed to a sink. But several recent studies concluded that old growth forests are stronger sinks for carbon than we previously thought. They do have a slower sequestration rate, as I've mentioned a few times, but they have more carbon storage at any given moment. And they maintain that positive carbon balance much longer than we expected because of the growth patterns of the living biomass that's in them. So the older forests are still accumulating carbon in their living biomass and their litter, and then the shade-tolerant species in the sub-canopy, so that younger generation of trees that comes in, helps to sequester carbon that replaces or fills the gaps that the dead trees leave behind as they slowly decompose and release carbon. So when a tree dies, that tree's biomass or carbon takes decades or centuries to release into the atmosphere through decomposition. And so overall, if the dead tree decay respiration is less than the photosynthesis, then the ecosystem can be considered a carbon sink. So there's less being released into the atmosphere than is absorbed. But the productivity here is declined, so there's very little sequestration in relation to storage. Okay, and then the third thing to consider in terms of managing for carbon is thinking about an increase in wood use. And that can be done by harvesting through harvested wood products, material substitution, and energy production. So this is an example of the physical carbon pools that are in the forest. And you'll notice that at the bottom, the soil carbon remains fairly constant. The living biomass is shown in the light green. And every 40 years, this is a 40-year harvest cycle, which shows a drop in that living biomass. So you'll see this is growing for 40 years, and then that drop here, that's where the harvest occurs. And this is the new trees that are growing over the 40 years, and that's the harvest. And the long lift, and then these other sections are where the carbon that's cut goes, the other pools that they go into. So the long-lived products last through the next harvest period, and the short-lived products don't. So here's the short-lived products, and here are the long-lived products. So they make it to the next harvest system. And the dotted red line shows the carbon in the system that would have been stored over the 100 years. And so what we're seeing here is that if you were to leave the forest over the 100 years, the sequestration rate begins to slow down. And this shows that the potential of being able to store carbon in the system after each harvest is actually a bit more than if the trees were left as trees. So there's the living trees in addition to the carbon stored in the products from what was in the live trees. And so, and this is just a quote about material substitution, that life cycle inventory analysis revealed that the lumber, wood panels, and other forest products used in construction store more carbon and emit less greenhouse gases and use less fossil energy than steel, concrete, brick, or vinyl, whose manufacture is energy intensive and produces substantial emissions. And so if we use wood products, then the idea is that the carbon is stored and there's less greenhouse gas emissions if those other materials were used. And so here's an example of the carbon stored in lumber, steel, a concrete block, and then CLT is cross-laminated timber, and so that's a new technology that they're using to build those large skyscrapers with. And so that's another consideration of this advancing technology, is that they create long-lived harvested products that, instead of just being used in furniture and home construction, now can be used in building construction. And wood utilization can even go further into using wastes that go into all sorts of different engineered wood products to help store carbon. And then the last is just to consider is energy substitution. And that's just basically the substitution of woody biomass for fossil fuels. And considering that biomass can offset coal, natural gas, gasoline, or fuel. This isn't a huge market yet, but we can, if industries were to develop, they could have the potential of supporting rural economies and fostering new industries. And the idea is that they would reduce emissions associated with extraction and transport of the other fuels. And they're most effective when you use them as byproducts. So woody wastes, or the end of the cycle. So for example, lumber that can't be reused or reclaimed, or chips from, or sawdust that's used in a mill that goes into creating fuel to run that mill, for example, are ways that you can use substitution energy. And then, so logging residue, forest products, industry waste, landscape fuel reduction projects. So if you're doing if you're reducing the fuels on a site to reduce the potential effects of wildfire, then using that for woody biomass, and then storm damage cleanup as well. Okay, and so those are the three main things that one would consider when managing for carbon. So increasing forests, maintaining the carbon on the site, and then managing for wood products. And so that's what I have for you today, and I'll be happy to answer any questions.
Thanks, Lauren. That was a lot of really awesome information. I think one thing that stuck with me is that you said you can't manage forests both for taking up carbon and storing at the same time at both high rates. That's something I never would have thought of. So thanks for bringing that up.
Sure.
Yeah, one thing that comes to mind is, you mentioned, or you showed forest soil in a couple places that popped up. I think it showed up in the graph that up to almost half of carbon in forests are stored in soils. And then you also talked about when there is harvest going on, one way you can protect the soil is putting down the slash and driving over that to prevent erosion. And where I'm going with this is I'm wondering, since soil plays such a big role in forest carbon sequestration, are there other actions or management techniques that people can utilize to help enhance the soil's ability to uptake carbon or protect it to be healthier? Anything you'd recommend?
Yeah, sure. So there's a few things that you can consider. One is just sort of maintaining as much, forest cover as possible. So the more plants and trees that are on a site, the more that it infiltrates the rain so that it doesn't cause excess of runoff. Obviously, if you're doing a harvest, that's reducing the amount of vegetation, but leaving slash out on the ground will help do that purpose as well. And also, roads are a main area for soil disturbance. And so making sure that you have really well-maintained roads, you're using rocked roads where appropriate. And if you're driving in the winter, you're definitely using rocked roads. You have good ditches and use culverts correctly. And that just makes sure that you keep as much soil in place as possible. Because those are areas for a lot of, if they're built incorrectly or not well maintained, there's a lot of soil loss in those areas.
Uh-huh.
So I would say those are the main things that I would consider for for making sure that maintaining soils. Oh, and something that actually your organization works on a lot is biochar, which I forgot to mention. So using, if you are deciding to burn slash, you consider using biochar. Actually holds on to a lot of the carbon, and it's supposed to be really great amendment for the site as well, and helps reduce drought effects and things like that. So those are some things to consider.
Awesome. So are there any other any resources or places you'd recommend for landowners who are interested in learning more to go, particularly maybe around some incentive programs or places they might learn more about the different types of markets available for folks considering trying to plan, harvest, and manage their forests around carbon storage?
Yeah, so that's one of the struggles, right? So in the slide that I mentioned, that where you could, choose to have fewer rotations in order to sequester more carbon on the site, that comes with a trade-off of potentially losing some income. And so there are some programs out there that you might be able to apply for in order to get back some of that, get back some of that investment. We don't currently have a carbon credit system in Oregon, but there are carbon credit systems in California that there are some nonprofits that work with small landowners that you could potentially sign up for your forest to store carbon and get carbon credits for that. So there's some of those systems available. And I can send you a couple of nonprofit organizations that you can put up as resources for that. And then otherwise, a lot of it is just sort of the individual's interests right now. Right now, it's mostly the individual's interests and personal objective. So that currently we rely on the policies being made to be able to create investments or incentives for people to do this work. And right now, the incentive is your interest and want to do it.
Mm-hmm. Okay, thanks. Clinton, did you have any questions that came through on YouTube or any that you wanted to ask?
Yeah, there were actually quite a few questions that came through. And I guess I just want to check, forests are complex, carbon capture is complex. We're hosting this meeting on YouTube. There's a lot of anonymous voices out there talking about this on YouTube. You can find pretty much anything you want on YouTube on the topic of climate change or carbon capture. Some are good faith actors, some might not be. And, you've been really clear about the evolution of our understanding and how some of these ideas are evolving and growing, and some are even controversial. You put your name on this work and you do this work every day, and you work with people on the land making decisions for what works for their forests. So I guess I have two questions for you. I think one, can you speak to how forest managers are thinking about these things every day? How mainstream these considerations are becoming for folks who are actually doing the work on the land? And then how do you address questions from folks that are like, why are we even talking about this? I wonder if I'm sure you get those questions all the time. So I wonder if you could just speak to those a little bit.
Well, I guess I can say that the people that I mostly work with are small woodland owners in Lane County. And, there's varying interests and or reasons why people own their land or choose to manage it. And so the reason why I created this talk or started doing research for this talk was because I was getting a lot more interest from landowners really concerned about the effects of climate change and ways that they can do their part. It's a really big issue. A lot of people hear it described as, an existential crisis. And as a single person, what can you do to help fix an existential crisis? And so, for people who own forests, they hear a lot about planting trees and how that could be a good thing. And so, a way to do their part is to consider ways that they can manage to try to at least store as much or sequester as much carbon as they can so they can do their part. So, there are definitely people that are interested in it. Not everybody, but there are definitely some, and that's sort of what started me being able to, diving more into this research to make some of these options or available to people so that they could do their part if they wanted to. And the second part of your question, I think, was how do I address people who say, why are we even thinking about this? Was that it? Yeah. Well, so in my role, I provide the information and allow people to do with it what they will. And so my goal is to provide research-based information. If the landowner owns the land, right now it's their right to manage it how they choose. And so they could say, I don't care what you have to say, and manage for the way that they want. And that's okay for them. So I tell them that's fine. The information's out there if you need it, if you have questions. And if you don't want to use it, that's okay too. I can help you manage for another objective if you're interested.
Awesome. Well, 90% of our watershed is privately owned, and the majority of our work is with private landowners. That's one of the beauties of it, is that folks can, find the solution that works for them. So I'm really glad you're out there providing that support. We did have one other question come in about the relationship between the microbial community and the soil and herbicides. I wonder if that's something that you have any experience with or can speak to, knowing the relationship between microbes in the soil, carbon, and other nutrients.
Yeah, I don't have a lot of experience with that, so I'm gonna say I won't speak to that. But if that person wants to reach out to me and send me an email with their specific questions, I can work with some folks on campus to get the exact answers they need.
That's great. Well, make sure we communicate that. Thank you.
Sure.
Yeah, thanks for sharing all that information, Lauren, and for helping to frame the conversation in a very complex topic by providing very clear information out there for folks. Really appreciate it.
Thanks. And like you said, it's a complex topic, so if people have questions, they can reach out to me.
Yeah,
thanks for having me.
Yep, thanks for being here. Next, we're going to welcome in Amanda Rao as our next speaker. She serves as OSU Extension's Fire Program Specialist for the Willamette Valley and the North Cascades. She's previously worked for the Nature Conservancy as their fire manager for both Oregon and Washington. And Amanda has robust experience in fire-adapted ecosystem restoration and conservation. She's got experience with prescribed fire and fuels treatment planning and implementation, as well as training, outreach, communications, and engagement. Welcome, Amanda. We're really excited to have you, and feel free to take it away.
Thanks so much, Rob. It's a pleasure to be here. I'm just going to go ahead and launch right into my presentation in the interest of time. It's so great that there's lots of good questions and great presentation by Lauren. Thank you. Okay. Here we go. Okay, I'm going to get started. And this talk begins with this painting by Paul Kane from 1847. And I start with this because I think it's important to get a picture of what the Willamette Valley looked like prior to the exclusion of fire. And I want to be clear about why I use the term exclusion rather than suppression. Suppression sort of implies that that fires weren't being lit for good reason, that fires were just bad and they needed to be suppressed. But the people to whom have been referred here as the Kalapuyan, the people of the Kalapuyan language group, used fire extensively in the Willamette Valley to manage for their cultural resources, as well as for the protection of themselves and where they lived from wildfire. That has been documented in their history and stories. And so we know people have lived with wildfire well here in the past. And I think it's important to refer to that and to look at the landscape as it was encountered by the early colonial settlers. They didn't really understand what they were seeing. It looked as though it was manicured. You see more wildlife here. I mean, you don't see any people here. You just see wildlife, and you see, isolated trees and savannas and some low-lying woodland areas, but a lot of open country and a lot of sinuous edge effect where fire was doing its work to create heterogeneity across the landscape. And this heterogeneity created an abundant landscape for cultural purposes, as well as a protected landscape from wildfire. The map on the left-hand side shows wildfire history in the Coast Range, starting in the late 18th and going up through the early 20th centuries. And you see this associated with different kinds of vegetation types. Oak savanna and upland prairies, mostly characteristic of the Willamette Valley, although there's a little bit of that closer out to the coast. Sitka spruce, lodgepole pine, hemlock, and cedar forests, wetland prairies and tidelands, Douglas fir forest, and woodlands. And all of them are affected by wildfire. When you look on the right-hand side of the screen and you see the language groups of people that were living in these areas when these wildfires were occurring, a lot of these people still live in these areas today. And we noticed that they were living in the places where wildfires were occurring. Some of the wildfires were lightning ignition, some of them were from humans. But regardless, there was a lot of fire on the landscape, and it was very much associated with the people that lived here, but also with what we sort of think of as these fire regimes, which I'll talk a little bit more about here in a minute. So this painting is just another example, and this is to indicate some of what I would consider to be the less intentional forms of fire. Fire that was incidental, associated with camps and places where people congregated frequently. And it produced what we actually see already today, or what we see today, which is open areas next to timbered areas. These look like clear cuts. It looks like kind of an even-aged rotational harvest situation, but it's not, it's fire. And so people living with fire meant that they didn't necessarily control ignitions. They didn't necessarily try to keep their campfires from doing something like this upslope. They were very much fire adapted in ways we could probably all be enviable of today. So looking a little more closely here, just at the Willamette Valley, I think it's important to account for what are really quite nuanced relationships between vegetation types and fire return intervals. So mean fire return interval essentially refers to the average return of fire to a particular piece of ground. And this is taken from a data set called Landfire, and it's frequently updated, and it's utilized for planning purposes. And so what we see is that the more frequent the fire that we have, the more that we see open land characteristics. Upland prairie of about 750,000 acres, emergent wetlands and wet prairie, another 330,000 acres, upland herbaceous communities and savanna. All these places are ones where we would see that return interval fairly frequent, 6 to 15 years, according to Landfire. I would argue it's more frequent. Some places were burned every single year. When David Douglas first arrived to explore the area, he was unable to find forage for his horse at one point because the entire Willamette Valley had been burned off. So really a frequently visited landscape when it comes to fire. And we know that as you move up into the, what I call the rings of the bathtub, or you move up into the ecotones where vegetation types change, you see reductions in fire frequency. But you also see fire frequency reductions associated with gallery forests, for example, really wet cottonwood forests that rarely dry out, except for perhaps in a year like this, that simply aren't available to burn very often. And those are going to be in that 1,000-year mean fire return interval category. So really interesting when you think about the interactions between forests in the high country up in the Cascades and the fires that were occurring within them as related to fire ignitions that were occurring in the Willamette Valley bottom. Notably, I'll mention too that, and this was what I actually did my master's on, is huckleberry burning was occurring in the high country of the Cascades as well. And those were frequent fire return intervals. So you had people who were burning huckleberry patches on the Cascade Crest throughout the summer and into the fall as they migrated. In some cases, they weren't migrating, but there was a lot of people moving through the Cascades throughout the summer for hunting and gathering purposes. And they were lighting fires to regenerate huckleberry for berry harvesting. So you have that going on. You have all of this fire in the valley bottom, and then you have lightning ignitions and other human ignitions happening in between. So to explain a little more about what a mean fire return interval is and how does that fit into this big picture here that I've shown you. Well, we all know what flame is. That's oxygen, heat, and fuel. So if it's too cold, a flame will go out. If there's not enough oxygen, it will go out. And if it doesn't have fuel, it will go out. So those are the three things that are required. When you have a fire event relative to wildfire on the landscape, then you have weather, fuel, and topography. Notice the constant there is fuel. And then within a fire regime, fire events occur. And they occur at different frequencies with different intensities and burning at different severities, depending upon a bunch of different conditions, including climate mean and variability, vegetation type, topography, and other regional controls, including local weather patterns, for example. And so that ends up becoming part of a longer term super fire regime. And this has to do with whether or not a biome persists or changes and long-term variations in climate. I think that we're probably starting to see shifts in super fire regimes, in addition to definitively shifts in fire regimes with climate change and increases in, well, I think this is the part to understand. We don't actually have as much fire on the landscape now as we once did, but we have too much of a certain kind of fire because we've excluded everything that's pretty easy to put out. That is indigenous fire management practices and burning, and the low to moderate intensity fires that are easy to suppress. So we've essentially selected for very high severity fires by taking away all these low severity fires and putting out the ones that are easy to put out. So that is causing shifts in our fire regime. And that will eventually cause shifts in what we call the super fire regime. So essentially our present day actions are affecting the future. And that's because we're not acknowledging our past very adequately in terms of how fire has shaped the landscape and how people have worked with and lived with it for a long time. I'm not going to go into the history of fire suppression or exclusion here with regards to things like the 10 a.m. policy and the fires of 1910, because that could be a whole talk on its own. But I'll just acknowledge that we more or less had a reaction to some very tragic events in the early part of the last century, not dissimilar to the ones that we just experienced in 2020 here in Oregon. And the reaction was to double down and treat fire as the enemy and try to get rid of it as much as possible. I'm not sure we've really learned our lesson from that. It changed enough, but I think we're in a different mindset today. There are a lot of people, especially I think in the science community, as well as the management community, who recognize that we are fighting a losing battle here. And to learn from the past means a hopeful future, in my humble opinion. So I'm going to start with a little bit on the 2020 wildfires here, and then I'm going to do some comparing between what happened in 2020 and what we're seeing today, as well as comparing with further into the past. So we're looking first here at the drought monitor and the outlook, 2020 versus 2021. These dates don't all sync up exactly. Obviously, I just pulled stuff for current conditions on the left-hand side. But on the right-hand side, you can see in 2020, we were in drought. We're heading that way in most of Oregon, or at the very least, we were abnormally dry. And we had outlook showing that would be continuing here and also developing in sort of the margins there and expanding throughout the West. Well, I think this, this is valid through August, so this doesn't really apply to here, but we've only seen persistence and increases in drought to a fairly significant degree. And we've heard, I think we've all heard about that. So that's not news to all of you, but it's kind of nice to look at what was setting us up in 2020 versus what we're setting up for right now, and what is impacting current fire behavior that we're seeing on the landscape. So now taking another comparison at what 2020 versus 2021 was looking like for wildfire seasonal outlook. For August and September in 2020, we actually weren't showing the northwest corner of Oregon as having any real above normal potential all the way through September. And we saw that all parts of Oregon, including the northwest part of the state, were affected by the conditions then and the wildfires that resulted from them last year. And so this year we see everything is, for the most part, worse off. For some reason, they're showing that by September, the southeast part of Oregon is going to not be in such trouble, which is good considering how the bootleg fire has been burning and what's the impacts of that fire on firefighters and communities in forest conditions. So now we're going to dive a little bit into fuel moisture, 1,000-hour fuel moisture. So what is that all about? 1,000-hour fuel moisture refers to dead fuels that are 3 to 9 inches in diameter. And the reason that this is important is because it tracks long-term trends in fire danger. So by comparison, what we call a 1-hour fuel, and these are time lag fuels, and they roughly refer to the amount of time it takes for fuels to gain and lose their moisture. And so 1,000 hours, obviously a lot longer time than a 1-hour fuel. A 1-hour fuel changes with the conditions throughout the day in a very short period of time. And, but it doesn't tell us much about the overall seasonal trends because they don't really vary a whole lot. And so what we see here is that in 2020, we started off at almost the exact average for our 1,000-hour fuel conditions as far as their moisture content was concerned. So we were above 30% starting off in May. And, you know, it came up above the maximum by mid-May. So it was pretty quickly started to spike up, but it dropped back down again. And then it stayed pretty low. And you can see, you know, what happened by Labor Day. Where were our 1,000-hour fuel moistures? Well, they were, you know, in that 10 to 15 range. Well, that's where we are right now. So, you know, assuming we don't get significant rain and conditions continue to go in the direction they're going, we can expect that fuel moistures can continue to get lower and perhaps set more records as 2020 did there. As you can see, that's lowest recorded for 1,000-hour fuel moisture. So now looking at energy release component, which includes 1,000-hour fuel moisture as one of its primary inputs. Energy release component really has to do with that sheer power that's behind the fire, that's being released by the fire. And it's a combination of a bunch of different elements, but that 1,000-hour fuel moisture is a key component. And that's because there's a lot of energy stored up in a 1,000-hour fuel versus a 1-hour fuel. A 1-hour fuel can have more potential to move and create long flame lengths and react quickly to fire, but a 1,000-hour fuel can create conditions under which the control is very difficult because of that sheer volume, that mass of energy that's being released from the fuel. So we see in 2020, you know, we had actually some of the lowest recorded energy release component values starting off. And by 2020 Labor Day fires, we had the highest recorded ERC. So in that 1 year, we see both sides of that, right? Well, this year, we've barely touched down and we've remained extremely high and have broken the record several times already or met it. And we dropped down a bit because we had some moderating weather conditions over the past week that have really helped drop that ERC down, but it didn't take long for it to jump right back up again. And so here we see it trending up to set maximum values once again with a fair number of fires on the landscape currently. So what is it that makes these fires really burn? Well, you know, it's combinations of fuel, topography, and weather. And so we know that the weather conditions right now are sort of coming to a place where they are favoring large fire growth, but the wind component isn't necessarily there in terms of the east winds. We have the fuel component, and then of course topography varies by fire, but it is consistent. So the two things that are really changing are the fuels and the weather. And in the absence of an east wind event, perhaps this isn't as concerning, but once you add that onto here, then we have conditions that are actually worse than what we had last year in 2020 during the Labor Day fires. So I wanted to show you kind of for scale and also to look at sort of across the landscape here in Lane County up the Mackenzie, what kind of fires we've seen in recent history, and what the holiday fire looks like for scale. We've had a lot of fire, starting here. I think the earliest year recorded in this is the Clark Fire in 2003. Then you got Scott Mountain 2010. A bunch of fires in 2017 did nothing but good for the most part on the landscape in terms of good conditions under which fires could burn. Because I could do I could and have done a whole other talk on just 2017 fires. And it's remarkable because we actually had a full spread of conditions, everything from the highest 1,000-hour field moistures and the lowest DRCs ever recorded to the other side of lowest 1,000-hour field moistures and highest DRCs. But there's a lot of space in between those two metrics. And that's the time during which a lot of these fires burned. And they burned because the overstory and the old growth and the topography and the lack of access was significant enough that if a firefighter were to have gotten injured, they would have had a really difficult time extracting them to safe place for medical treatment. And so crews were just not willing to go hike up into those woods to try to put those fires out. And their success might not have been very good anyways, just surely due to that volume of fuel, really difficult fires to suppress. But if you look at them today, a lot of them look really good. And it was because they were burning under those more moderated conditions. There was a nice thick layer of smoke and clouds that was keeping the sun from reaching the fires, which reduced the solar radiation impacts and really helped keep things moderated. So I think this is important to just note because we are seeing things change very quickly right before our eyes. We had all these fires here for a while, 2003 through 2017, 2018, that were probably within the historic range of what we think normal is. And we're doing nothing but good on the landscape. And then all of a sudden we've got this huge fire that burns down an entire town and changes people's lives forever. And so what are we going to do about that? And how are we going to prepare for that better? Really important questions to ask. So I think it's important to understand what's contributing to this. We have climate change, but we have climate change on top of the Pacific Decadal Oscillation. And those are multi-decade climate patterns that are, normal, if you will. But you add climate change on top of that, and it really exacerbates those already existing patterns of change and oscillation. So when we started fighting fire, and really fire exclusion started a long time before suppression did, just so you know. And some of that was not intentional. It was intentional in the terms of the eradication of indigenous people, but it wasn't intentional in terms of knowingly taking indigenous fire out of the picture and creating some of these problems. But fire exclusion started more like the mid-1800s, early to mid-1800s in a lot of the West. The suppression part started in 1910, and thereafter with this paramilitary response to the 1910 fires, the era of the Big Burn. Well, that was a warm, dry period too. Then we really got into a nice, cool, wet period, and we had really active fire suppression that was very successful. Now we're in this warmer climate period again, and we're seeing that increase, and we're seeing human activity and its contributions also increase. So I think it's just good context to understand that this isn't all human created. A lot of it's human created on top of existing patterns that would already cause these changes to happen. So I just wanted to quickly just kind of address that these fires are significant. The 2020 fires, the ones we just experienced and ones we're experiencing now as well, but they are not the largest wildfires in Oregon history, not even close actually. Beachy Creek is the 12th largest wildfire in Oregon's history now. And then you go down from there from 2020, Lions Head, Holiday Farm, Riverside, Archie Creek, and it goes from there. And so we know that fires have burned to a scale of more than 1 million acres. The Silverton fire, which actually Beachy Creek and Lions Head both burned within. We've got Yaquina, Nestucca, Tillamook. Those are all Coast Range fires. And the Coast Range is the place we say never burns, but when it does, it really gets going. And we also know that under the climate change scenario of an increase of 2.2 degrees Celsius, that we can expect to see these acres continue to increase and the area burned continue to increase. So The holiday farm fire footprint that we see relative to all those previous fire footprints is probably going to happen again, maybe not in the exact same place, but in other places. Although we could also see some reburns of these fires from 2020. If you look at Tillamook, the Tillamook fire, the original one, then proceeded to reburn on the order of like every 5 years thereafter. So it's important to note that just because a fire burned does not mean that it won't burn again. And we need to be prepared for an era during which we can expect to see larger areas burned and perhaps more intensely. So I think it's important to recognize that we have a different story here and a different way to address our story here. On the west side, on the east side, it's a pretty straightforward equation in terms of seeing low severity fires replacing less than 25% of the dominant overstory. It can include some mixed severity, but generally you're not seeing a replacement of the overstory, a very significant amount. And that's every 0 to 35 years. Where we're sitting, we see this mixed bag of every 35 to 200 years, although a lot of the research that's coming out of OSU's College of Forestry by folks like Andrew Marshall, James Johnston, are indicating that we have in some parts of the Western Cascades even higher fire frequencies than that, almost certainly due to anthropogenic or human ignitions, indigenous burning, that frequent topic that keeps coming up. So I'm going to quickly run through slides of what does the natural role of fire in dry forest look like, and then I'll show you my attempt to create a visual, because unfortunately Van Pelt, who created these visuals for us, did not create them for our wet west side. So we'll look at what fire does in dry forests. At year 0, this is what it looks like having already had frequent fire. It burns and it looks something like this. Not much different than the first picture at year 40. And then it burns again at year 60. And then it looks like this. Basically, it looks about the same, a little bit of change, but nothing significant. But when you take that out, this is what it looks like, and then you have huge problems. And so this pattern is simple. It's low intensity, regular intervals over space and time, and it's a fairly straightforward prescription. You thin and you burn. That's basically what you do in dry forests. Well, the west side is this very different story. First, I created this, by the way, because Van Pelt didn't make this. So this starts with a graphic by Franklin et al. From 2017 showing the common successional pathway following disturbance in moist Douglas fir forests. So you start off as year 0, you've had a big fire, the whole overstory is taken out. And this is the disturbance and legacy creation. And then you start to get a little bit of forest growing in, but you're also going to get a low severity fire that does some work to clean things up a little bit. You start getting plant canopy closure, and then you start getting some low to mixed severity wildfire. And then eventually, as it becomes overdue for stand replacement wildfire, you get that stand replacement and it goes back and starts over again. So it's a complex pattern of varying intensity, extent, and frequency over time and space. And that makes it a difficult thing to manage. So I'm going to do my best to explain to you what that really looks like. But first, I want to just note that Douglas fir establishment on the west side of the Cascades has always been regionally episodic during periods of widespread fire. With tree farming and industrial logging and other forms of harvest and maintenance of that value system, which is now more dominant, this is not necessarily applicable, but there's a reason that clear-cut harvest is used as a technique for Douglas fir. It's because it likes these open conditions. It is not shade tolerant. And so when fire comes in and takes all the shade out, Douglas fir competes really well. And then other cohorts of shade tolerant trees will eventually start to come in after the Douglas fir has been established, species such as Western hemlock. And so this is just important to note in terms of understanding how these warm, dry climate periods relate to the establishment of Douglas fir as related to wildfire occurrence. So now we're going to shift into what do we do? How are we going to manage for fire in different ages under these even age management scenarios? So I broke this up into 0 to 12, 12 to 25, and 25 plus in terms of options for what you can do to try to manage for fire in a sort of non-natural setting. So most private landowners, for example, or folks that are tree farming. Well, we know that if we reduce the canopy and cover Then we increase drying and wind exposure, which also means that by reducing canopy cover, we're going to encourage some surface field development where there's productivity. And but we also have reduced crown fire potential. So in almost all cases, when you do something here, you have a trade-off. So you may not have as great a crown fire potential, but in a clear cut that's really open like this, but it's drier and perhaps more prone to burn during a longer period of the year than it would have been otherwise. And then on the left-hand side, these are just cover classes kind of showing, anything from very sparse to very dense and where those breakpoints are for typical conifer forests. And then you just think of all those open dots on there as places where things get sun and they can grow, particularly surface vegetation. So not so much the trees, although they will grow up in those spaces too. So I went ahead and I modeled for 4 different scenarios of vegetation and fuel types to look at what kind of crown fire potential, flame lengths, and rate of spread could be expected. So if you're able to maintain a tight canopy and you're pruning your trees and you're maintaining them, but you just have ground cover of short needle compact timber litter, then even under pretty extreme conditions, which is 8-mile-an-hour wind speed, fully cured fuels, 40% slope, and 6% fine dead fuel moisture, which is pretty well cured, you're only seeing less than a foot flame length, less than half a foot flame length, and less than half of a chain per hour rate of spread. Chain per hour is 66 feet. And people kind of laugh about this archaic term, chains per hour, but it's very, very common in fire to be used. And so that's the measurement used here. You get into very high broadleaf litter, and this we're talking about, our oak and pine overstory. And so here you see a little increase. You get quite a bit of increase, 3.6 foot flame lengths and 4.7 chains per hour, some moderate crown fire potential. And on the previous one, there was low crown fire potential. So it's a slight increase, but this is still something that could be managed by firefighters. And the reason I say that is because 4 foot flame lengths is the break point at which firefighters are not supposed to directly engage in suppression action for safety reasons. So if we can keep those flame lengths down below 4 feet, that gives firefighters a better chance of being safe and effective at their jobs. And a lot of what I talk about here is aimed towards that end. So moving into high load of grass and shrub, this is your blackberries, grass, brush, just fuels that haven't been managed. And boy, you jump up pretty fast, 10.3 foot flame lengths, 10.9 chains per hour, and high crown fire potential. And then the last scenario is high loads of slash or blowdown. So this is pretty much all dead fuel, heavy loads, a lot of it. And now you're looking at 13 foot flame lengths, 60.8 chains per hour, and high crown fire potential. Extremely difficult to control. So in order to manage for these different fuel types and their fire behavior potential, we have to look at things in terms of the field bed strata. So the first one we look at is that horizontal canopy. How do we thin and break up the crown fire potential? And maybe that's not the first, but we'll just start with that and work our way down. When you get into the surface fire realm, you're really looking at reducing surface and ladder fuels, and mastication could be one means of accomplishing that. And then as you get to the ground level, it literally is raking. I know that that's been joked about, and it's certainly not a tactic that can be used across the landscape, but around your house, it's actually a really good idea. I do it around my house just to keep the dead fuel away from my house. In that case of an ember landing from miles away, as happened in the Holiday Farm fire. So trying to employ all of these methods will really give you the best chance of being successful. So understanding, how your forest can be managed depending on fire resilience, stand age, access, habitat constraints, et cetera, is really important. So here's some management options and trade-offs. The first is just to really increase that crown base height and get rid of those ladder fuels. So that involves pruning. There's really not a lot of trade-offs. This is probably the most easily performed task that has the least negative consequences, other than a little bit of tree injury. And if you're pruning ponderosa pine at the wrong time, for example, and there's large volumes or large diameter of material being produced, that might be an issue, but you kind of have to hit, I think, that 4-inch diameter before that's really a problem. So talk to Lauren about that one. She's helped me with thinking through that stuff in the past in terms of when to cut ponderosa pine, for example. And it does produce slash, so you might want to manage for that. Light thinning and pile burning is a great option for pretty much all size classes, although there's not much of a need up through that 12-year. Most people aren't thinning, up to the 12-year range. So really 12 to 25 and 25 and over. Oh, excuse me. It's important to take care of your slash if you're going to thin. I really encourage that. And of course, with the removal of that canopy, there is potential for some of that surface fill loading and decreased canopy cover. Looking at thinned or partially cut stands that are older, again, it will increase that surface fill loading, but it can, really help break up the canopy and reduce that crown fire potential. So, you kind of look at how much canopy base height you have, how much of the crown's touching, and how much light is getting to the forest floor, and you can kind of find that sweet spot. Unless, of course, you start experiencing mortality in your overstory and other issues, and then you really have to kind of rethink your whole strategy and what your objectives are. Mastication can be used in any age class. It's really just a rearrangement of fuel, and if you know you're going to burn, I'm not sure it's the best option because it can produce a lot of smoke from smoldering. When I say if you know you're going to burn, I mean if you're going to be implementing a prescribed fire, it's not a good thing to do before the prescribed fire, but it can really help retain moisture and fertilize and have a mulching effect. If you're trying to suppress an herbaceous layer of weeds for some reason, it might be effective for that. Just know that it's rearranging as opposed to removal of fuel. And then my favorite, which is broadcast and understory prescribed fire. This is my, primarily my background is in this kind of work. It does require practical skills, water delivery equipment, permits, and management of smoke, but it's generally the most effective economically and ecologically. It, of course, does require liability insurance considerations, which can be a barrier for a lot of folks. But I will put a plug in for the newly authorized Certified Burn Manager Program, which was just passed under Senate Bill 762, that will enable private citizens to get training in implementing prescribed fire on their land with alleviation of liability, some protection from the state. So keep your eyes up for that. We'll be working on the rulemaking this summer, and then we'll start working on the program and executing that over the next year or two. So really excited about that, and hopefully we'll see more of that option used in the future. And then maintaining your access and potential control lines. I can't emphasize this enough because firefighters being able to get into a place and be able to actually take action is huge. Maintaining fuel breaks so they have something to work with. And maintenance is the thing to do here, because once you decide to do something, chances are you're going to have to maintain it, because we have such great conditions for growing things here. Photosynthesis works well. We have great soil. We have a temperate climate. And so we have to keep after it if we decide to take action to reduce fuel and fire risk. And so to kind of summarize here, just the latter half of my talk, and these are the take homes, is, fire has been here for a long time. It's played an important role in shaping our ecosystems, forested and otherwise. If we want to create safe places for firefighters to protect our homes and our land and our natural resources and our investments, we really need to do our part to help them. We have to remember that fuels on the east and the west side of the Cascades respond very differently to fuels treatments, and they require different kind of maintenance. And just really getting a better handle on how your forest or property can be managed for fire resilience, depending on all these different factors, is really important, and will enable you to hopefully weather a fire event more successfully, and also to, again, make sure that firefighters have a good place to go to work, because they're doing a lot for us out there. And the more that we can do our part to set them up for success, the more likely that they're going to be safe and successful in their efforts. And with that, I think I'll go ahead and take questions.
Thanks, Amanda. Really appreciate you sharing all that information. I appreciate how you emphasized how fire is an important part of our history, and it's an important part of healthy ecosystems. And to that end, I'd be remiss if I didn't mention your incredible partnership on the building prescribed fire capacity in the Southern Willamette Valley project. You've been working a lot with our ecologist, Katie McKendrick, and local nonprofits, tribes, public partners. Wondering if you wouldn't mind just briefly describing your role in that effort and just kind of broadly, what kind of outcomes do you hope to see come out of that project?
Yeah, that's a great question. So when I was still working for the Nature Conservancy as the fire program manager, a lot of my work involved being a burn boss and implementing prescribed fires here in the South Willamette Valley. And so I had started working with Katie because she knew a lot of private landowners were not able to get private lands burning done. And then she also had been working with the tribes, the Siletz and the Grand Ronde tribes, because there's a need for them to increase their prescribed fire capacity as well, especially on lands that they own and they are managing for their own purposes. And so she put in for this grant with the Oregon Watershed Enhancement Board, which I helped out with. And she got it, which was great. And so I've been working with her and a couple of other folks from Eco Studies Institute under contract to take a look at the need for increased prescribed fire capacity, the windows of weather that we might be missing, because we kind of put ourselves in a little bit of a box saying we only start burning here and we burn till then. And then we realized maybe we were missing some opportunities and we should be looking a little more broadly. And then we're creating a tool that can be used to help fire managers make decisions about when to burn, and doing so in partnership. So I think the most notable thing about the prescribed fire work in the Willamette Valley is it's done through partnerships, and it's done for the greatest good, particularly with conservation values in mind. So as opposed to, when I was in my former role, TNC, I wouldn't say, well, I want to get my acres burnt today. It was, well, what habitat type are we trying to get at? What is the value there? Oh, well, there's streaked horn lark here and I don't have lark there. So we'll go burn your lark unit and we'll get to mine later. Or we have to get this done in a specific time because of planting and that sort of thing. So we were really getting into coordinating, but we didn't have a good actual system. It was all through our relationships. So trying to put on paper a lot more of that stuff to make it more institutional so that different people can pick it up and use it rather than it just being dependent on individuals. So one of the things that came out of me leaving that job was, oh no, Amanda's gone. What are we going to do? We need her for burning. Well, it's not about Amanda's gone. It's about a position being vacated and needs to be filled. And how does the institutional knowledge then get used to be, passed on from one person to the next? So this fall, I think the most exciting thing that's coming out of some of that work, as well as other work that I've been doing with Katie, is burning at the Andrew Reesner Wildlife Preserve with the Confederated Tribes of the Grand Ronde and Siletz. And the Siletz tribe has been building its fire capacity. The Grand Ronde has fairly well-established fire capacity. So it's kind of working with them both to help see how we can continue to grow that out and support the tribes, primarily really working on focusing on supporting the tribes in their use of fire and their increasing capacity for themselves to use fire on their own lands. So it's really exciting work. It's great to get to partner with Katie. She was so helpful to me when I worked for the Nature Conservancy as a volunteer. She coordinated volunteers for TNC. And so we're just kind of continuing some of that work, but working for different organizations, or at least I am now, and working with some different partners. Really exciting.
Yeah, it is. It's super exciting to think about the possibilities, and really appreciate all the help that you gave Katie in crafting that grant and thinking about not just the partnership, but the possibilities and the vision of how this could all come together. I know she's talked a lot about how much you've meant to that program. So thank you. Another question that comes to mind is, we think about climate change and conditions that tend to be top of mind is like, okay, things are getting warmer, things are getting drier. I'm curious, do you have a sense of how climate change may be shifting wind patterns, like the directions of the jet stream, or maybe increasing the speed of winds? And are there conditions related to wind speed and where wind's coming from that might be producing more severe and intense wildfire too?
Yeah, so I do know that increased wind speeds are associated with climate change. and they are associated with increased warming. So as you get warmer conditions, you do get higher wind speeds. But another thing that's important to understand is that after you've had a wildfire, it no longer shields from the wind as much. And so up in Detroit, in the areas that were affected by those fires, they've had these horrible dust storms. There's been a lot of, so wind can move more readily across landscapes that have burned. So that means that the landscapes that haven't burned are getting hit by a higher wind speed as well. So yes, we can expect higher wind speeds. We've already been seeing them. I think folks have said that the east wind event that occurred last fall was, well, that's just a rare event, but I don't know that it's going to be as rare as it has been in the past, given a lot of the predictions around climate change, in particularly increasing wind speeds. I don't know the degree to which it's going to change wind directions, although if we get more of the kind of high pressure movement that high pressure troughs that move over an area like the Cascades in the fall, which produces these east wind events. If we see more of that, then we're going to end up seeing more east winds by default. But that some of that remains to be seen. I can just say for sure in the sense that what I know from climate change research, that wind speeds are expected to increase for sure.
Interesting. You shared a lot of information about tips and management strategies people can do to help mitigate wildfire risk on their property. Is there any resources or tools? Obviously, OSU Extension is a great place to go. Is there any tools that you'd recommend people go for further reading or places to continue kind of learning up on that topic?
I actually have found there not to be a whole lot of information on fuels reduction for wildfire risk in northwestern Oregon. And it's possible we'll end up creating a publication to that end, because there's something for Southwest Oregon that's pretty useful that folks have been using. And I can provide some of those resources and follow up. But I think that, Oregon Department of Forestry has some good guidance on that. We always say this, but, reach out to your local stewardship forester because they can help you with more of the nuts and bolts and details of like what you can thin and when you go into their system to enter in your activity that you have planned, it will flag things that you need to consider, like adjacency to a fish-bearing stream, or whether you have a nesting endangered species in your area or something along those lines. But I think that the fact is we have focused on really like slash hazard reduction for the most part in northwestern Oregon, because we are a timber producing part of the state, and most of our fire concerns have been around slash, pile burns, that sort of thing. So, you'll find those resources pretty readily if you go do a search for them. What's harder to find is things about trade-offs from different management approaches and what to consider. So I guess I could tell you to stay tuned.
Yeah, it sounds like there's a gap and a need for that to be created. But yeah, that's a good reminder about the stewardship foresters. I think Dave and Glenn brought those up as well, and we'll put some links out on our website so people can get connected to them. Clinton, did you have any questions or anything come in from YouTube?
Yeah, I had a question for you, man. It was impressed upon me looking at the topics of both your presentation and Lauren's that we're kind of hitting two sides of the climate issue in some respects, sort of looking at slowing the pace of climate change and how we are addressing carbon and release into the atmosphere and storing more of it in the forests and in the soil. And also, how are we sort of mitigating the impacts of the changing climate that are seemingly inevitable and that we're all experiencing now. And hearing you talk about things like Indigenous co-management of lands and returning and reconnecting people to a cultural practice. And the bill that you talked about to bring training to private landowners, it also landed with me that we're talking about not necessarily only techniques and the science of it, but also these social and cultural limiting factors to doing the right thing. And it seems like just in the last year or 18 months even, we're looking at like a moonshot for how do we address the fuel loads in the forest? How do we return fire to the landscape. And I wonder if you could just reflect on some of those social limiting factors to getting this work done. And how do you think about that?
Yeah. So I think that cultural shift is slow, generally speaking, in my experience. And I think when you're trying to see that change happen within a large institution or an agency, such as the Forest Service, who essentially has, more or less ownership and control over fire. It has for a long time. I know people at ODF might not like to hear that, but nationally speaking, they have owned fire, really. And so you take an agency that went from European silvicultural practices applied to an indigenously managed landscape. That's the first thing they do. And there was an argument going on for a little while between so-called Paiute forestry or indigenous burning practices and European silviculture. And European silviculture won that argument, and that became the thing that was done. That means protect trees. It means keep fire out, because guess what? Europe didn't have a lot of fire in the forest. In Europe, most of the burning was occurring for agricultural purposes. There's some fire management and burning that happens for silviculture, but for the most part, it's agricultural. And so they didn't have that. And so you see that the suppression era is still upon us. We just had a letter issued from the whole head of the Forest Service saying, we're going to suppress all fires. There's no more managed wildfires. It's kind of going back in time to previous approaches to management. That's how hard it is to change that culture. So that culture influences all of us. Everybody knows who Smokey is. We shouldn't blame Smokey, by the way. That was a well-intended campaign. People love to blame Smokey. It's not Smokey's fault. And we still do need fire prevention campaigns, frankly. I mean, I like to use the slide showing indigenous people living well with fire and not putting their campfires out, because we should all be inspired by that, but it doesn't mean we're ready to be there yet. So then we confuse people, because we tell them, don't let anything catch on fire. But then we're saying we need more fire in the landscape of the right kind. And this is what this history was all about. So, most people are frankly confused, and it's hard to hold space for competing ideas, which is we need more good fire on the landscape. We don't have as much good fire on the landscape as we used to, but we're all scared because we have so much bad fire that's chasing us around right now that we didn't get ahead of until now. And now we're going, oh no, we better do something. Do we have time? I'd like to think we still do. I keep the hope that we can still turn the clock here, but we don't have much time. I mean, my whole career has been dedicated to try to get fire on the ground before bad things happen. And I left the Forest Service to go work for TNC because I couldn't help from the inside. And I thought maybe I could help more from the outside. Now I'm at OSU because I think if I can change hearts and minds, maybe that'll make a difference. So that's why I'm here. Because I want people to understand, and I'll show up and give these talks to try to help have these conversations, because it is hard. And I think it's understandable why people are confused, because they've had all this history and now we've got all this other stuff that we're telling them, and they're going, what should we do? I think most people at this point understand the need for prescribed fire in the landscape. I think the hard part to understand is when to let fires burn, whether to let fires burn when they're so-called natural ignitions. I think all ignitions are sort of natural, by the way. It's, they're all part of us in nature, but that's another story. And another cultural issue, that's the social factor in why we're here, because we get into that dichotomy. And it's like, why do we even talk about that? Why does the Forest Service have a policy that they can't let a campfire that gets out of the ring burn for natural or managed wildfire? So there's a lot of causality issues. And I guess the last thing I'll say is that I can go and fight a wildfire and I can make all kinds of mistakes. And everyone says, oh, she did her best and she was managing an emergency situation. But if I go have those same problems after I drop a match as a burn boss doing a prescribed burn, it will come back on me. And so people don't choose to become burn bosses because that causal burden is so strong that they know if they mess up, it's going to be a big deal and it's really stressful. Whereas if you go fight a fire and you mess up, there's a few mistakes that will get called out really high level, but generally not, because you were doing your best. So I think once we can, take that pressure off people who light fires on purpose for the right reasons, in the right place, in the right time, we'll see a change. I could go on about this, obviously.
I did too. I mean, so the human dimensions and natural resource management, I mean, that's certainly my wheelhouse. So I appreciate your answer. And it's interesting, I'd never thought about it before, but just the PR hurdle of fire is really different than, it's sort of, it's similar to rain is good, flooding is bad. Wind is good, it keeps the bugs away until it's a windstorm and, or it's a tornado. Can we have the same nuanced conversation about fire, about when is it good and when is it bad? And so I think there's certainly a public relations hurdle in front of us. And I'm grateful that you're in the position you're in to help us navigate that. So thank you.
I got a really quick story I'm going to tell that relates to the video
Please.
of Tom Bowman and Lindsay Reeves. Tom's my cousin, by the way. I have a vested interest in that property. There was a lightning strike just to the south of it last week. And I hiked in there to make sure it didn't start a fire. And it was really thick, gnarly country to get into. And I'm seeing fire scarred big old trees because it's an old growth area that's been excluded from that management activity for spotted owl. And I was sitting there at that moment holding that same space going, this is a fire adapted landscape. This fire was meant to be here. And I'm here to make sure it gets put out as soon as possible. So there you go.
Well, I think that's actually a really evocative image of someone who cares about this and thinks about this and nonetheless is feeling the tension of that it's not, given everything that you spent your entire career doing, that it's still not an easy thing to grapple with. And so it's illustrative, of course, the broader community having to grapple with it without that experience. And so I think that's a really great story. And if folks haven't had a chance to see the video with Tom and Lindsay, after this is over, just click on over a couple of boxes and you can watch that and get some context for what Amanda just mentioned. So thank you for that. That's really, really heartening to hear, actually.
Yeah, thank you so much, Amanda. And thank you, Lauren. Really appreciate both of you providing your time and giving of your expertise. All of you are volunteering your time for this. I think I want to mention that, like you and Glenn and Dave have been excellent partners at OSU Extension and giving us your expertise and resources. So like we've been closing with the questions here, this is a super complex, complicated topic with a lot of nuance to it. There's the intersection of biological and social and climate factors that all weave together. So that's why we took 2 meetings and a supplementary video to explore this topic. As we heard from our speakers, you could have other numerous topics that dovetail off of this. We're going to continue having this climate-focused series of public meetings with an agricultural-focused one this upcoming winter, where we're going to bring in some folks to talk about how a changing climate is impacting folks in the ag community. And as a reminder, this video will be up in perpetuity on our YouTube channel later, so you can check that out later on. And then lastly, I want to put in a plug for our annual celebration and fundraiser, which is going to be the very last week of September. We're calling it a week of celebration, and it's going to feature a series of small outdoor tours that folks can sign up for on our website. There's going to be one at Wintergreen Farm in Notai, one at Snagboat Bend along the Willamette River, and then one at HIV Alliance, one of our business partners, where we did a stormwater rain garden project a couple years ago. So then at the very end of that, on September 30th, we're going to have a live event that we are going to use to celebrate our accomplishments, elect board members, give out awards to folks in the watershed, and give out some prizes to you all. So you'll see more of that information posted on our website and in our newsletter in the coming weeks. Thanks to everyone for tuning in, and have a wonderful night. Good night.